Workplace hazards are numerous and can exist in various forms. Employers are responsible for identifying these hazards and providing a workplace free from serious recognized hazards using control measures when needed. Exposure control in the workplace can be done using hierarchy of controls. The effective order of action is elimination, followed by substitution, engineering or administrative controls, and the use of personal protective equipment. Personal protective equipment, commonly known as PPE, is equipment worn to minimize exposure to a variety of hazards. Gloves are an example of PPE worn to protect skin from various exposures like chemicals, biological materials, excessive heat or cold, and lacerations. Appropriate glove selection is essential for carrying out tasks where most manipulations are done using hands. Are you confident that the glove you are wearing is appropriate for the work you are performing? Gloves should be selected based on the task being performed, duration of use, hazards and potential hazards identified, and the conditions present. This video will focus primarily on appropriate glove selection for chemical usage. By the end of this video, you should be able to select gloves for your specific task and understand some basic guidelines for effectively using gloves to protect yourself. Gloves are available in various materials, thicknesses, and in different lengths for different applications. Materials that offer chemical resistance to glove can vary. A popular glove choice for low-level hazards are the disposable nitrile gloves. Latex gloves are less prevalent due to the concerns of allergic sensitization reactions to latex. Depending on your applications, other commonly used gloves are butyl, natural rubber, neoprene, polyvinyl alcohol, silver shield, and Wettehahn. These materials can vary in thickness and can be blended or laminated. Glove thickness is measured in mil, which is equal to 1/1000th of an inch. Thin gloves with lower mil values are usually disposable, offering short-term protection and meant for single use only. Thicker gloves with higher mil values are typically reusable and offer more substantial protection against hazards. Gloves can also vary in length, with longer gloves offering more surface protection than shorter ones. Gloves are generally tested and rated by glove manufacturers in two main categories: permeation and degradation. Both these criteria should be considered when selecting gloves for specific applications. Permeation is the process by which a chemical passes through the glove without going through holes or other visible openings. The video clip shows acetone permeating through nitrile gloves upon full contact with the chemical for over 1 minute. The acetone that passes through the gloves dissolves the nail polish in the layer underneath. Permeated gloves often appear unchanged to the human eye. It is important to remember that no gloves will remain completely impervious to specific chemicals forever. Therefore, it is crucial to determine how often you should replace your existing gloves. You may often find terms like permeation time or breakthrough time and permeation rates mentioned in glove selection charts that are useful to make these determinations. For example, in this chart for nitrile gloves, the permeation time for acetone is 1 minute. This means that nitrile gloves can only be used for splash protection when working with acetone and should be immediately changed out if the chemical contacts the glove to prevent it from getting onto your skin. Degradation is the change in the physical properties of a glove caused by contact with a chemical. Degradation typically appears as hardening, stiffening, swelling, shrinking, or cracking of the glove. Degradation ratings indicate how well a glove will hold up when exposed to specific chemicals. While glove rating charts serve as general guidelines for the effective use of gloves as PPE, it should be noted that manufacturers perform permeation and degradation tests under lab test conditions, which can vary from actual conditions in your work environment. Often, for chemicals that have not been well characterized or new, the line between safety and risk is blurry. In 1997, a well-known metal toxicologist, Dr. Karen Wettehahn, spilled a few drops of a potent neurotoxin, dimethylmercury, on her latex-gloved hand while preparing some calibration standards for her NMR experiments. Safety data sheets at the time recommended wearing rubber gloves. So when just a few drops spilled on her glove, Dr. Wettehahn didn't think too much of it. She removed her gloves and washed her hands. Since the chemical was clear like water and hadn't burned or otherwise deformed her gloves, she didn't think there was any reason to panic. But the chemical had permeated through her latex glove in less than 15 seconds and seeped through her skin. Latex gloves were later found to be terribly insufficient for working with this extremely dangerous chemical. She soon began experiencing progressively worsening signs of mercury poisoning, which eventually led to her death. Post-accident glove testing results showed that pairing silver shield with neoprene gloves was the only guard against dimethylmercury. Here are some general guidelines and best practices for glove use. Always perform a thorough risk assessment for proper glove selection before beginning your work. For low-level hazards, where an occasional splash or drip can occur, when handling chemicals, the standard disposable nitride gloves are sufficient. However, when handling moderate to high-risk chemicals like corrosives, toxins, or chemicals that can readily penetrate the skin, use an appropriate glove material that offers substantial protection. Don't use nitrile gloves just because they are easily accessible. Ask yourself if they are appropriate for your task. For mixtures, choose a glove with the longest breakthrough time, considering all the chemicals in the mixture. Consult the safety data sheets of the chemical reactants, solvents, and products in the experiment to determine the most protective glove material that can be used. This information can be found in Section 8.2, Exposure Control, Personal Protective Equipment. Make sure to wear gloves that fit you properly. Inspect gloves for rips and tears before every use. Remove and replace disposable gloves immediately when a chemical spills or splashes on them. Do not spray your hands with alcohol. Doing so breaks down the glove material, leaving you more susceptible to any spills or accidents that may occur. Never wash or reuse disposable gloves. Always remove gloves before touching common objects such as doorknobs, phones, or elevator buttons. Follow the correct technique for removing gloves and discard them properly. Wash your hands thoroughly after removing gloves. There are millions of known chemical substances and chemists are creating new ones every day. Always treat experimental and high-hazard chemicals with caution. When using especially dangerous chemicals, consider double gloving and changing gloves frequently. The appropriate selection and use of PPE can help prevent or limit unnecessary exposure to hazardous materials that could lead to serious harm, including death. Occupational Health and Safety Administration reports that over 71% of hand injuries can be prevented with the appropriate use of gloves as PPE. Your hand and health safety matters.